Good morning, students. Now we are studying the other aromatic nitro compounds and their reactions. Before this, we studied the monoaromatic nitro compound, that is nitrobenzene, its synthesis, properties and uses. Now we will study the other aromatic nitro compounds and their reactions, and they are di and trinitrobenzene. The dinitrobenzene are of three types. They are meta dinitrobenzene, ortho and para dinitrobenzene. The meta dinitrobenzene can be synthesized directly from nitrobenzene. The nitration of nitrobenzene gives the meta dinitrobenzene, because we know that the nitro group is meta directing group. This meta dinitrobenzene, when react with ammonium sulfide alcoholic, the NO2 group is reduced and we get the meta-nitroaniline. The NO2 group converts into the amino group and we get the meta-nitroaniline, and further reduction with sodium sulfide we get meta-phenyl diamine. Both the nitro group reduced to the amino group and we get the meta-phenyl diamine. The reaction of meta-dinitrobenzene with potassium ferrocyanide in the presence of NaOH, OH group, that is the nucleophile, is attached on the benzene ring. That is the nucleophilic substitution reaction take place and we get the two types of product, that is 2,4-dinitrophenol or 2,6-dinitrophenol. This 2,4-dinitrophenol is a major product in this reaction. So these are the reactions of the meta-dinitrobenzene. The another compound is ortho-dinitrobenzene. The ortho-dinitrobenzene cannot synthesize directly by the nitration of nitrobenzene. The ortho-dinitrobenzene can synthesize by aniline. The nitration of aniline gives the nitroaniline, and then oxidations give the ortho-dinitrobenzene. But for this, the nitration of aniline, we have to first protect the amino group by the reaction with aniline with acetyl chloride. We get the acetaldehyde. Then the nitration of acetaldehyde give the ortho-nitroacetaldehyde with concentrate nitric acid and sulfuric acid. This ortho-nitroacetaldehyde on hydrolysis give the ortho-nitroaniline, that is anilide group converts into the amino group and we get the ortho-nitroaniline. This ortho-nitroaniline on oxidation with trifluoroacetic acid or with sodium nitrite in the presence of HCl, the NO2 group is the NH2 group is oxidized and we get the ortho-dinitrobenzene. So by this way we can synthesize the ortho-dinitrobenzene from aniline to the ortho-dinitrobenzene. The reaction of ortho-dinitrobenzene are the ortho-dinitrobenzene react with the nucleophile and we get the products in which nitro group is substituted. The ortho-dinitrobenzene react with NaOH and we get the ortho-nitrophenol. In this, one NO2 group is substituted by the nucleophile, that is OH minus. Similarly, the ortho-dinitrobenzene react with alcoholic ammonia and NO2 group is substituted by the aniline amino group and we get the ortho-nitroaniline is obtained. Similarly, if ortho-dinitrobenzene react with sodium sulfide, then again we get the ortho-nitroaniline. NO2 group is substituted by the NH2 group and we get the ortho-nitroaniline. Further reaction with ammonia with Na2S, we get the ortho-phenyl diamine, that is both the nitro groups are substituted by the are reduced to the amino group and we get the orthophenyl diamine. Similarly, the para-dinitrobenzene can also synthesize from aniline. The nitration of aniline also gives the para-dinitrobenzene, and it can also synthesize by dioxime, that is parabenzoquinone dioxime. When oxidized with nitric acid, the oxime converts into the NO2 and we get the para-dinitrobenzene. Also, the paraphenyl aniline, when oxidized with trifluoroperoacetic acid, then again NH2 group is both the NH2 group oxidized and we get the para-dinitrobenzene. So these are the synthesis of para-dinitrobenzene. The reactions of para-dinitrobenzene is similar to the ortho-dinitrobenzene. The para-dinitrobenzene react with sodium hydroxide, NO2 group is replaced by the OH group and we get the para-nitrophenol. Similarly, it react with alcoholic ammonia, NO2 group is replaced by amino group and we get the para-nitroaniline. And if it react with methanol in the presence of NaOH, the NO2 group replaced by the methoxide group and we get the para-nitroanisole. So these are the reactions of para-dinitrobenzene. Then the trinitro compounds, the trinitro aromatic compounds, they are of two types, trinitrotoluene and trinitrobenzene. TNT and TNB both are explosive. The TNT, that is trinitrotoluene. This can synthesize by the nitration of toluene. The nitration of toluene gives nitro compound nitrotoluene, and this nitration takes place in steps. In first step, the toluene with reaction with nitric acid and concentrate sulfuric acid give the ortho or para-nitrotoluene. Then this ortho or para-nitrotoluene again undergoes nitration with concentrate nitric acid and sulfuric acid at 80 degrees centigrade. We get the 2,4-dinitrotoluene, and this 2,4-dinitrotoluene on further nitration with concentrate nitric acid and concentrate sulfuric acid at 110 degrees centigrade, we get the 2,4,6-trinitrotoluene, that is TNT is obtained. So the nitration of toluene finally give the TNT. This TNT undergoes reaction, it oxidation reaction. The TNT when oxidized with chromic acid, the methyl group is oxidized to the carboxylic group and we get the 2,4,6-trinitrobenzoic acid. This 2,4,6-trinitrobenzoic acid, when heated, the CO2 is evolved and we get the trinitrobenzene, TNB. So TNB is obtained. So from TNT, the oxidation of TNT gives 2,4,6-trinitrobenzoic acid. This on heating get the trinitrobenzene. The TNT is used as explosive. Its two explosives are amitol and ammonal. The ammonal is a mixture of aluminum nitrate. It has 47% aluminum nitrate, 22% aluminium, 30% TNT and 1% charcoal used as explosive. Amitol is also a mixture of TNT and ammonium nitrate. It is also an explosive and its use in mining, especially is in coal mining. So this is all about the TNT. The next is trinitrobenzene, that is TNB. We have seen the synthesis of TNB in the property in the reaction of TNT. The TNT, when oxidized from toluene, the nitration of toluene, step by nitration of toluene, we get the TNT, trinitro toluene. This TNT on oxidation gives the trinitro benzoic acid. This on heated eliminate the CO2 and we get the trinitrobenzene. So this is the synthesis of TNB. As for the properties of TNB, if TNB react with a nucleophile, then nucleophile substitute NO2 group and we get the substituted compound. If it is OH minus, then we get the 3,5-dinitrophenol. The nucleophile can be OH minus, methoxide ion, etc. So with nucleophile, the NO2 group is replaced and we get the substituted compound. It gives charge transfer compounds also, because we know that TNB, the 3 nitro group on benzene ring, which are electron withdrawing groups, they decrease the electron density of the benzene ring. So benzene ring has a very low electron density in TNB, and if it react with the active compound like trimethyl benzene or polyalkyl benzene, this is the trimethyl benzene, the methyl group has a plus I effect. So by the presence of more methyl group on benzene, the electronegativity of benzene ring increases. So in trimethyl benzene, the electronegativity of benzene ring is very high, and in TNB, the electronegativity of benzene ring is very low. So it transfers its charge from trimethyl benzene to the TNB and we get the compound. This compound is formed, that is known as the charge transfer compound. So TNB with polyalkyl benzene give the charge transfer compounds. The another reaction of TNB when oxidized with potassium ferrocyanide in the presence of NaOH, it gives the picric acid. So picric acid can also obtained from the TNB. And another use of TNT, it is also used as explosive. TNT and TNB both are explosive, and TNB is more explosive than the TNT. So this is all about the nitroaromatic compounds, that is monoaromatic compound nitrobenzene, diaromatic compound and the triaromatic compounds. Thank you.